going to dive right into a panel on pH. We're very lucky to have both Ryan and Mark joining us on our panel today to talk about managing low pH. And Mark, in your video, you kind of talked about some of the causes, the background here of why, but boy, that chart was sure telling about, the native pasture land being close to 7, but everything else really going much, much lower. So can you maybe just expand on what specifically is causing this problem?
Yeah, so you really kind of have to look at all different sources of, of, of acidification, basically all your sources of hydrogen ions. And so there's some acidification that's sort of background, okay? So our rainwater, that's acidic, around 5.5 pH. Also, the mineralization of organic matter, that, carbonic acid, that is also another source of hydrogen ions. But those two contributions are relatively small compared to, and actually they play out over much longer time spans in order to see a measurable change. Even, we're talking hundreds of years in order to see those effects of those two factors. Where we're seeing the big changes is where we're intensively managing, where we have nitrogen being applied, where we're not maybe necessarily efficiently using the applied nitrogen. And it can also be exacerbated where we're pretty aggressive with our residue removal. So the residue that could be returned and could be returning, cations back into the surface soil depths, that's being pulled away. And so that you lose some of that buffering capacity, the hydrogen ions predominate, and then your pH drops.
And is this a problem you're seeing regionally or in certain pockets, or is this a pretty widespread problem?
Looking at the literature, it seems like it's becoming a more widespread problem. Obviously some soils that sort of lack the buffering capacity, say like a lot of the soils that we have in the southwest part of North Dakota, they don't have the buffering capacity, and soil acidification can get really quick. But if you look at particularly some recent meta-analyses in the peer-reviewed literature, it's pretty clear that we've got a widespread global issue with respect to acidification, and so there's a need to obviously understand its sources, but also identify some effective interventions regionally and by production system.
And Mark, is this something that's been talked about for a long time, or is this kind of coming to the forefront for any reason in recent years?
I think that it depends how far we look back. I think that these sort of issues sort of align themselves with the availability of nitrogen for growth of agricultural crops. So you can go back to the Haber-Bosch process, all right. So we can maybe take that back a little over 100 years. But as our production systems have intensified, as we have to some degree, some of our conservation practices, such as no-till, actually make the acidification issue maybe a little more severe, because you're applying the nitrogen in the same location every year, and you get this stratification. And so, as Ryan pointed out in his video really well, where we're seeing the really severe acidification is right there at the near surface, and that has a lot to do with the fact that, particularly in drier regions, it's to our benefit to use no-till for a lot of soil health related reasons. But with that can come this issue of decreasing pH. And so we have to find ways to manage it.
Excellent. And yeah, that's probably a good segue over to Ryan to talk about how do we sample for this? I know you said traditional sampling doesn't do a good job because it's right there at the very top. So how do you recommend to sample for this?
Yeah, I definitely prefer a 0 to 3 and a 3 to 6. If you're looking at your bigger soil samples, you're really diluting that pH, and you're not really seeing what's actually there, right? Yeah, with that 0 to 3, I think you want to break it down by how you've been applying your fertilizer. If you're doing surface applications, you're more likely to see that acidity in the top couple inches. But if you are putting anhydrous down where it's a little bit deeper, you're likely to see that low pH a bit deeper down.
Ryan, what have you seen from a management perspective that seems to be working to help, first of all, react to low pH, and then also maybe more proactively prevent the problem?
Yeah, we've got some great agronomists in this part of the state, and we've been trying a lot of different things. The best fix is really liming. That's really what we want people to do with this issue. But there are some kind of band-aid approaches to get by in the situation. So there is some, variety selection within crops like wheat. Lanning out of Montana has a gene that has aluminum tolerance, and we're trying to find some other varieties out there. Been doing some variety trials and that kind of stuff. There is some work out of both Oklahoma and Montana where you put phosphorus in with the furrow on small grains, and they're looking at about 50 pounds of phosphorus. Gets a yield in durum similar to that of a limed field where you have a more neutral pH. So the phosphorus is able to tie up or bind to the aluminum, so you're not seeing the aluminum toxicity. Because when we're looking at the pH, what we're really looking at is how those different nutrients become available, and things like aluminum and manganese become toxic, right? The aluminum's already there, but it's not soluble until the pH drops. So the damage we're really seeing in a lot of these crops is from aluminum. So if we can tie that up somehow, that can kind of get you by. But there's a lot of other issues that come from low pH, your biological activity in the soil, how herbicides interact with the soil. So there's a lot that plays with the pH. So ideally, fix the pH to start with. And that's with lime applications. And there's a few different lime sources, but it's not exactly cheap either.
I think you said in the video 5.5 and below is when you start to run into some of those issues. Maybe clarify that a little bit. And then also, do you wait until that threshold before you start that management?
So it depends on how you've been sampling. If you're doing a 0 to 6 or 0 to 12 and it's already showing that it's below 6, you probably have some bigger issues than you realize. If you have been doing 0 to 3 and you've really been pinpointing those issues, 5.5 is where you start to see issues. When it starts to really become a problem is when it gets below 5. And the thing is, this stuff really can snowball out of control pretty quickly once you start to, reduce. Some guys might not realize that they have it, and they're seeing, reduced stands in these areas. So maybe they're putting more nitrogen down to try to fix it or something because they're not looking too closely at the pH. And then it gets even worse.
And I mean, is this something where, the chart that we put up there during Mark's video was pretty bleak. Is this just something where a lot of people are going to have to inevitably fight this, or is there something that they can do with their practices short of like bringing back tillage to the point earlier that might help either slow or reverse this issue?
If you have the option to put perennials out there, so plants themselves aren't really going to change your pH to a point where it'll completely turn things around from an acidic soil. But if you put species that can handle a low pH environment, you can slow the process, because it is a natural process in many of these soils. And I think trying to reduce the amount of nitrogen you're putting down, trying to put out some grasses. Again, like Mark said, if you're removing material, you're removing a lot of those cations. So it's a natural process that's going to happen over time.
And what are some of your go-to crops as far as, more tolerant, Ryan?
You look at things like oats. I think I mentioned in the video, wheat, certain varieties. It's important to remember that certain varieties of certain species are more tolerant than others. It's a major issue that affects many different crops. There are, if you can't put lime down, maybe you can grow blueberries or cranberries or something that can handle acidity pretty well. But there's going to be some yield loss because you're just seeing that aluminum in there, and that's going to reduce your root growth. And it actually first starts to show up as like a phosphorus deficiency, because the aluminum, you start to see a tie up of phosphorus in these situations. So the impact of the nutrients within that soil is going to impact a pretty wide range of crops, and it might not be as apparent in some crops. Your warm season grasses can handle it better than most. Things like durum, barley don't do super well. Safflower does not do well at all. So your legumes are going to get hit twice as hard. Yeah, it's you have some options, but it kind of limits your rotation.
You said there's a couple different sources of lime, and not all lime is created equal. So is there a preferred source or preferred size of granular that you're applying to make this process, to make it work more efficiently?
Right, and it all depends on your operation and what you're able to do. You want to have a smaller particle size so that it can interact with the soil quicker. Things like, there's some pelletized lime that, it's very easy to apply, but it's a little bit spendier than some of the other options. So it's also, that it usually has a more standard particle size, so it's going to work quicker, but you're gonna pay for it. So that'll work. Beet lime, it works well, but you have to worry about bringing in weed seeds. But I do like beet lime personally. But if you're not set up to spread it properly, you could have some issues where it clogs up your spreader. It can be difficult to get a consistent rate out there. There's water treatment lime as well. That is pretty heavy in moisture, so you have to let it sit out for a while and can have some issues as well. Again, you want to make sure that you're looking at the amount of actual lime in that product. Like beet lime is 60 to 70% lime, so your actual rate of beet lime will be higher than your rate of lime is. So another option that Mark and I have been kind of talking about is if you have a dead tree row or you're kind of renovating a tree row, ash is a good liming agent too. Maybe if it's just a small spot in the field or something like that, pile up a bunch of logs there and make sure that you're safe with your fire habits. So.
And Mark, I know I asked you earlier if this was a widespread or more of a regional issue. We did have a question from the audience about if you've heard of this extending into the I-states at all.
Yeah. In fact, it's definitely here. I started my career in Nebraska, and we have acidification issues that are pretty rampant where I was doing my work in eastern Nebraska. Of course, mostly continuous corn with fairly intensive in application rates and really highly buffered soils, but we're still seeing acidification in those areas. And it's you would think with our soils here in the Dakotas, where we're just naturally buffered and they're fairly young geologically, that we would have some additional time, and that doesn't seem to necessarily be the case. I think this acidification is pretty widespread, so we need to really keep it in mind. I can follow on some of the suggestions that Ryan had, and I was thinking, culturally, things that we might be able to do to hold the line on pH. And Ryan said, if it's an issue where you can spot treat it and it's very focused, then going with a perennial where you're not having to apply nitrogen is a good way to just hold things in place. The other thing that I think we should probably think about is crop rotation diversification. Okay, is sequencing crops in a way to be able to make the most efficient use of the nitrogen that's in the soil. And so it's taking advantage of synergies between crops from one year to the next. And I think that's part of the reason why we're seeing sort of a less acidification under a dynamic rotation at the research farm there outside of Mandan, is that we're sequencing those crops in a way to take advantage of synergisms from one year to the next, and we don't have to apply as much N, and some of that N is coming by way of legumes, which we have to be mindful they can also create acidification themselves, but that release is slower and of the nitrogen is slower, and then we have an increased chance of being able to capture that the subsequent years. So I that's one thing. I'll leave it at that. There's some other things that we're seeing that's really interesting with sunflower that maybe we can touch upon later, but I just wanted to get that crop rotation component in to follow on Ryan's comments.
And Ryan, I know you mentioned earlier that eventually salinity could impact phosphorus availability. There's a question from the audience of if I'm sorry, I said salinity, acidity. There's a question from the audience that asks, does mild acidification help phosphorus availability?
So if you go into your old soil fertility textbooks, if you have one, so there's kind of this like, which book is it? It's in Brady and Weil. If you have the 2004 edition, it's on page 391. It does, it kind of has this complex with aluminum where it kind of gets bound up. So you actually see the opposite effect where you have less phosphorus available as that pH drops. You do see a lot of these things actually decrease as the pH drops when you get below 5.5. The thing that you do see increase is manganese as well as iron, but that manganese is to the point where it's toxic. So that's my understanding of it. I'm definitely not a soil scientist. I'm an agronomist, so my knowledge might be limited, but I think I said the right thing.
Mark, do you have anything to add on to that?
Yeah, that gets pretty deep into the chemistry. I totally support Ryan's answer there.
Good deal. All right, no problem at all. There was also a question about, the understanding that nitrogen lowers the pH only in a very small area and doesn't affect the overall soil pH. Now, I don't know if that's pertaining to the, very small level, like the very top of the soil, or what. But is that the way they're asking if that's what, if their understanding is correct, that nitrogen, excess nitrogen, is only going to affect the pH in a very small part of the soil? Ryan, could you maybe elaborate on that?
Yeah. So the nitrogen definitely moves, but I think the biggest impact that you're going to see is where the placement is, because that's where a lot of the biological activity is happening. That's changing that nitrogen into a different form that releases some hydrogen ions. You got to remember that nitrogen is everywhere, right? 78% of the atmosphere is nitrogen, but we want to turn it into a form that the plant can use. And when we do that, it reacts in the soil and releases hydrogen ions. So I think it's mostly going to happen where you place it. There might be small effects deeper down, but I don't know anything about that. So.
Well, and this might be pertaining to the video, I think, is where you talked about this. And I know we've mentioned it here in the panel as well, but can you elaborate some on how legumes can acidify soils or maybe exacerbate this problem?
It's still going to happen, but it's going to be at a much lower rate than your anhydrous fertilizers. So yeah, you're reducing the amount that you're acidifying it, but overall it's still a acidification event, I believe.
Right. Yeah. Oh, yeah. Absolutely. It is. But it's not as severe. I mean, you have to remember those nodules that are fixing nitrogen. Those will decompose, and there's a lot of organic N. So that's nitrogen that I always think about as sort of ammonium N. It's at sort of the top of the nitrogen cycle, and as it begins to get used by the microorganisms in the soil, it's going to be it's going to get converted to nitrate, and some hydrogen ions are going to get spun off into the solution. But it's not as severe. It's not as extensive as say it in an application of a synthetic source at a high rate. And so, and again, and also that decomposition, that availability of that nitrate is also happening at a slightly slower level. It's not coming as one big pulse. And so that's yes, there's acidification, but there's a higher chance that the subsequent crop is going to be able to capture and take up that available N from the previous legume, and therefore sort of counteract that acidifying effect.
It sounds like really a lot of the nitrogen applications we make to the soil in the form of fertilizer applications could be fine-tuned to help fix some of this problem. And so I don't know, Ryan, is that something that you're working with growers on, or are precision applications of nitrogen fertilizers to make sure that they're not over-applying and exacerbating the problem?
It's part of the conversation. I haven't done any research on it yet. Chris Augustine and I, director here at the Research Center, are in talks about putting some trials together on that. But at the end of the day, the better nitrogen use efficiency you have, the better off you're going to be. The less waste of nitrogen, the better. So, whether that's reducing rates or doing a split rate, at the end of the day, you need to have a yield. So you still need some form of nitrogen. But if you can give that nitrogen more efficiently, that's better. So.
All right, well, Mark, maybe we'll cut to you for some closing thoughts. Just anything that we didn't get a chance to talk about that you think is really important to include in this conversation, or anything that we did that you just want to build on top of before we round out this panel.
Just a couple of things, and this just touches upon a comment from Bill Spiegel there in the chat box about the crop rotation thing. So I did a sampling on 15 years of cropping system effects on a number of soil chemical properties. And very interestingly, found that we had a annual crop rotation that had sunflower as part of the sequence. And what we observed is that after 15 years, we actually observed that the exchangeable calcium increased where the sunflower was part of the rotation. It wasn't a large increase, but it did increase, but it only increased where the nitrogen levels were sort of low to medium. So we were being pretty efficient, maybe, certainly not over applying, but really dialing in that N level so we didn't have it in excess. We completely lost out on that gain of exchangeable calcium where we had the high nitrogen rate. So it just got flooded with acidification and flush those cations out of the near surface steps. So, it's not a real rigorous result, but it was one that really was interesting to me, that in fact, maybe we can think about root architecture, and here's a crop that has a tap root, and we talk about lime and applying it, and that is going to be a necessary intervention, but really we've got all kinds of lime 2 feet below the soil surface in the form of just the calcic horizon. There's a lot there. Maybe we need to think about how we can utilize our crop rotations to it's not going to turn around the acidification issue, but maybe it'll help slow it, and so we can kind of keep things under control. So I think that's where that diversification issue can come into place. And then finally, I sent a link on this whole thing about soil depth. It's so very important that if you think you have a pH issue, make sure you dial in your depth increment just right, because if you go with a deeper depth increment, you're effectively diluting the soil pH result, meaning that it'll be, you could have a very low pH, but if you sample through the top 3 inches down to 6 or even 12 inches, you're going to get a completely different story, and that would affect your application rate of the amount of lime that you would put on. So it seems like it's a lot of trouble to sample like 0 to 3 inches, but I think if you think pH is an issue, I strongly follow what Ryan said. I think that's something that it's worth the added expense, so you know exactly what you're dealing with.
Thank you, Mark. And to make sure I understand on the crop diversification in the sunflower, you're saying that maybe something with a deeper taproot might access the lime that's down there? Is that what you're saying?
I'm saying it's basically perhaps acting as a cation pump, and you have those, they're basically, they become part of the plant. That plant then, after harvest, it decomposes, goes back to the near surface, and after 15 years, then yes, you begin to see an effect. It's a small one. This is how these things change. It's very subtle, but I think these cultural practices, sort of play upon sort of the natural cycles, and we have to be sensitive to those subtleties, because I think we can use them to our advantage. And if you can marry the best of the cultural practices with the very best technology to put nitrogen on at the right time, at the right place, at the right rate, then we can go a long ways to slowing this acidification trend in our region.
Oh, thanks so much, Mark. And Ryan, I want to go to you for some final thoughts, either something you're wanting to bring to the panel or something you want to build on top of.
Yeah, so when we talk about applying lime, it's important to remember that the important part of that calcium carbonate is the carbonate. That's really what's changing that pH drastically. Those base cations are very important, but for that kind of large change that we want to see, we really want to see that carbonate. And that will then kind of turn into CO2 as it goes down. But so it's important to remember that gypsum, it might have calcium, but that's not going to change your pH in a major way. The sulfate in it, actually, I saw a few things that shows that the sulfate can actually bind up to the aluminum, but it's just a fairly small amount. There was a question in the Q&A about putting lime in furrow. I did a trial with that this past year. In soybean, we saw a slight yield bump and reduce the amount of, we did some pretty extensive tissue sampling. We saw an average of like, we dropped from 45 parts per million of aluminum down to 30. So it's still more aluminum than you want to see in the plant, but it did reduce it at 75 pounds of lime in furrow. There was no difference between 75 and 100, and there's no difference between 0 and 50 pounds. So if you're putting lime down, I'd rather you put down a lot of lime on the surface than a small amount in furrow. But maybe there is some aluminum. You're stopping some of the aluminum toxicity and giving it a slightly better environment to start root growth. But I'm still a little skeptical on that. There are definitely some Band-Aid approaches out there. I'm going to look a little bit further into gypsum to see if there is something to that sulfate tying up the aluminum. I just kind of continue looking at this. There's a lot of different, the more I look into it, the more I realize that we don't know, and look around because we're not the only ones facing this issue. So see what other people are doing out there. So if you have any questions, feel free to contact me, and thanks for having me on.
Yeah, thank you, Ryan, and thank you, Mark, both. I think it's a really important topic, and I'm sure one that will come up again in the future because it sounds like there is a lot of need for more information on this. So thank you both for the time.